Recording in progress.
Good morning. This is your Stats Sensei, Mr. Spensei, and this is Unit 2, Displaying, Describing a Data Depth Packet, problems 91 through 100. Given the cumulative plot above and the most commonly accepted definition of outliers, what ages would be considered outliers? Well, we need to calculate our IQR, and IQR equals Q3 minus Q1. So I need to find those. So my Q3, I'm going to go across at 75 and drop down. I find Q3 is 50, and I go to 25%. I drop down and I find Q1 is 40. So 50 minus 40 gives me an IQR equal to 10. Well, to be an outlier, X must be less than Q1 minus 1.5 times the IQR. So in this case, Q1 was 40, so 40 minus 1.5 times 10. When I go on the calculator, 40 minus the 1.5 times the 10, I end up with 25. So I need an X value less than 25. So anything less than 25 is an outlier. So we know for sure that this could possibly be it. And we also have this. The rest of these are out. But I need to check the high side. So X greater than Q3 plus 1.5 IQR. And Q3 happens to be 50. So 50 plus 1.5 times 10. So 50 plus 1.5 times 10 gives us 65. So we need X greater than 65. Well, I can see that my graph stops at 60. We have 100%. So we shouldn't have any values greater. And we look at our answer choices and 65 is not there. So the possibility is anything between 25 and 20 would be considered outliers. So anything less than 25. Because remember, 25 technically is not because it's on the fence. So what is the approximate interquartile range? This is 92. All right. And the graph below shows cumulative proportions plotted against GPAs for high school students. Well, remember, it says interquartile range, IQR equals Q3 minus Q1. So we go to our graph and we draw as straight as possibly can, drop down, and I'm going to say maybe about 3.1. And I go here at 25%. Well, there's 30. 25% is probably going to be about here. Drop down, and maybe about 2. I don't know. So I end up with 3.1 minus 2. Well, there's nothing close to it. There's nothing that's really close other than a 0.85. And that error is probably in my reading of the graph. All right. Because this is probably a little bit higher. But regardless, the only possibility is 0.85. Suppose the scores on the exam have a mean of 75. Okay. Mean is 75 with a standard deviation of 8. If a student has test result of negative 1.5 and a second student has a test of 2, how many points higher was the second student than the first student? Well, you need to know the z-score formula. Z equals x minus mu over sigma. So in this case, we don't know the x's. So I'm going to plug in what we do know. We know the z-score of the first one. We know it's a negative 1.5 equals student 1 minus the average over 8. So negative 1.5 times 8 equals plus 75. And I find out that that student made a 63. So x1 equals 63. The other student had a z-score of 2, and there's student 2 minus the mean of 75 over 8. 2 times 8 plus 75 equals 91. So x2 equals 91. And they said they wanted the difference. So 91 minus 63 is 28. Our answer choice is E. All right, moving on to 94. Boy, that's gotten blurry. Hopefully that'll clear up. There it goes. The graph below shows the cumulative proportions plotted against the number of employees working in mid-sized retail establishment. What is the approximate interquartile range? Again, IQR equals Q3 minus Q1. So if I come across here and I go, well, I try to draw an illustrator. I drop across and I go, okay, that's about 50. And maybe 75. 75 minus 50. Well, that didn't help me out. Equals 25. Let me check to see if I can make that a little more accurate. There we go. Boom. Okay, that's closer to 70. And the 25, that's pretty close to that 50. So I'm going to say my answer, I come up with about 20. The one that's closest is 18. Even if I had been sloppy and gone with 25, the closest would have been 18. If 10 executives have salaries of 80,000, 6 have salaries of 75,000, 3 have salaries of 70,000, what is the median? Well, the easiest thing to do would be to go to your calculator and input that data. So if you give me just a second while I go to stat edit and clear some stuff out. So stat edit, clear that out, clear that out. And we have 10 executives of 80,000. So 80, 1, 2, 3, enter. And I'm just going to put a 10 next to it because that's my frequency. The next 6 had salaries of 75,000. So 75,000. And I go over. And that was 6. And 3 have salaries of 70,000. And I go to stat, calc, 1var stat. L1 is my X list. My frequency is an L2, so second 2. Scroll down 1, and I get a median of 80,000. All right, I get a median of 80,000. Now, I could have probably done that just by thinking about it, because if I lined them all up, the middlemost value is 80,000. All right, what are the mean and standard deviation of the payoff variable? So this is basically going to go into L1, and this is going to go into L2. So 0, 500, 5,000. 0.7, 0.25, 0.05. Stat, calc, 1 variable stats, L1, L2. And I have a mean of 375 and a standard deviation of about 1,082. So 96 would be B. The number of hybrid cars a dealer sells weekly has the following probability distribution. The dealer purchases the cars for 21,000 and sells them for 24,500. What is the expected weekly profit? Well, first off, what's the profit on any one car? The profit on any one car would be 24,500 minus the 21,000 gives me a profit of 3,500. The question is, how many cars does he sell? So that's going to be our X, the number of cars he sells. And this is going to go into L1, and this will go into L2, and we'll calculate a mean. So stat edit, clear that, clear that. And we have 0, 1, 2, 3, 4, 5. 0, enter 1, 2, 3, 4, and 5. and we have 0.32, 0.28, 0.15, 0.11, 0.08, and then 0.06. I go stat calc, one var stat, L1, L2. I find out we expect to sell 1.53 cars a week. So $3,500 per car, and we expect to sell 1.53. So 1.53 times 3,500 equals $5,355. My answer choice is C. Suppose the starting salary of a graduating class are as follows. What is the mean salary? All right, so this is going to go to L2 because this is my frequency and this is my X value. This is what they're actually going to make. So stat edit back to the top and clear those. And I have 15,000, 20, 25, 30, 35, 40, and 45, and 10, 17, 25, 38, 27, 21, 12, stat calc, one var stats, L1 and L2. And I get an X bar of $30,533. Best choice is B. You can choose one of three boxes. Box A has four bills, four $5 bills. All right. So box A, four $5 bills and a single $100 bill. So let's go look at that. Stat edit. It has four $5 bills. So you can get $5 bills or you can get a $100 bill. All right. But it has four of these and one of these. Stat calc, one var stats, L1, L2. And I find box A, I expect to get 24 bucks. Box B has 400 $5 bills and 100 of $100 bills. So stat edit. And it has the same thing, but it has 400 of these and 100 of these. Stat calc, one var stats. Oh, I still get 24 bucks. Box C has 24 $1 bills. You can have box C. Well, if you get box C, how much are you getting? 24 bucks. Either A or B, but not C. No, all of them have the same thing because with box C, you're getting everything out of that box. So they all have the same. All right. So box A and B were exactly the same. In C, you're getting everything from out of that box. Given two independent random variables, X with a mean of 12.3 and standard deviation 0.5, and Y with a mean of 9.1 and standard deviation 0.3, which of the following is a true statement? Well, X minus Y, 12.3 minus 9.1, 12.3 minus 9.1. What do we get? First off, we can subtract means directly. I end up getting 3.2. All right. But this says mean of 21.4. No. Median is 3.2. We don't know anything about the median. We know the mean. We don't know anything. We don't have the range values, so we can't give that. The standard deviation is 0.8. So they said to find the standard deviation, we'd have to go 0.5 squared, and we can't subtract them. We have to add them, and 0.3 squared. Then we have to take the square root. So here we go. 0.5 squared plus 0.3 squared. Now I'm going to raise that value to the half power. Oh, wait a second. It gave me a variance. The variance is 0.5 squared plus 0.3 squared. That's my variance. And when I did that, I got 0.34. And that's a true statement. All right. So for 100, the variance, oops, I circled the wrong one. I said the right thing. The variance is 0.34. And remember, you cannot subtract these things. You cannot subtract them. And when I took the square root, I got 0.58. So the standard deviation is 0.58, not 0.8. So my answer choice is E. All right. Okay. Hope to see you on the next one. Thank you for watching.